Okay, so we had learned in the last class fundamental and derived unit, and I had asked you to learn the definitions. Okay, definitions
Yes, sir.
of those, right? Now today, that day we had discussed that in SI units, uh, this light intensity, mass, time, etc., and luminosity, and also finally we had seen that steradian and radian. There are two units which are again uh, used or being like we'll be using in our study. So this is radian and steradians are the units of angle, plane angle, and solid angle. First, let me. So this will be my basically my context today. So the context is plane angle and solid angle, and then I'll be discussing how to measure the length, like large large distance, large distance by parallax method. Okay, and second thing, very small size using some indirect method. Okay, indirect method. These are obviously indirect method. So actually this is oleic acid, oleic acid method. So very small size we can measure. Okay, so let us first start with this solid angle and plane angle. What are those? What is solid angle and what is plane angle? Just a minute, my screen is coming. Okay, so actually this chapter deals with measurements and units. So how we can measure the fundamental units, sorry, fundamental uh, parameters like length, mass, and time, etc. So length, we have smaller length, we have larger length. So how we can measure smaller length, larger length? Similarly, mass, small mass, greater mass, etc. How we can measure, and how we can measure time precisely. So those are the context over here in this chapter. Oh, so okay, so here it is. What it is. Okay, so let us see. So first is plane angle and solid angle. So plane angle you have been learning since your like lower standard, like 6th, 7th standard onwards. So the angle, uh, suppose, so plane angle, actually this is defined as, see, we write as theta, suppose this is defined as the arc length by the radius of a circle. Okay, by the radius or radial distance. I say radius. So suppose I have a circle like this, okay, circle, and this is the radius, and suppose this is the angle theta, okay, and this is generally denoted as the arc length from going from A to B, and the angle is theta, and suppose this is r, radius. So theta will be actually s by r. And this is planar angle in the sense it has two things like r and theta, okay. So these two positions will be having r and theta, even though in this case r is constant, so you will have like coordinate r and theta. So this is a two dimensional quantity or planar quantity. This is planar quantity, and you look, this is a dimensionless quantity because this also is the dimension of length, and this also has the dimension of radius. Both are length, so length by length there is no unit, but still we write this as a radian, okay, radian. What is this called? Radian. In short it is rad. In short it is rad. The value will be in short as rad, okay. So we have a relation actually, like you have pi radian means pi rad means 180 degree, or vice versa, 180 degree is equal to pi rad. Okay, so you can actually convert like 1 degree, or maybe, yeah, 1 degree means how much radian. So pi by 180 degree, 180 radian, you have to say this as radian, okay. So each angle can be converted into radian unit, okay. So this is actually see, this angle is actually radian unit actually, angle is actually unitless, but we give a name as radian, okay. Both are, because this also length s and this also length, both are length, so length by length, so unit will be cancelled out, okay. So this is actually plane angle. So when you have a circle and 2 points A and B are making an angle at the center O, so that angle is theta, that can be denoted by the arc length in between these 2 points A and B, that is S divided by R. R is the radial distance, okay, radial distance from that arc. So sometime it will be given like this, okay, sometime it will be given like this. So suppose it is R, or maybe it is B, and this is D, okay. So this is theta or alpha, whatever. So theta will be written then D by B, okay, like this. So yeah, so this is plane angle. Now we'll see what is solid angle. So this solid angle, this is a kind of three-dimensional quantity, or maybe I'd say not three-dimensional, maybe two-dimensional quantity, I can say. See, I have a, see, when I in the previous case I had taken a circle and then I had taken 2 points. That means a arc length, which is making an angle at the center. Okay, an arc length is making an angle or subtending an angle at the center. So that is a plane angle. But if I have a sphere like a football or tennis ball, whatever you take, okay, you can take a short football also. So that is solid sphere. So suppose I have a sphere here, okay. So like sphere is not like, so this is actually a surface. If I like show you here, like like you have this surface, okay. This is the surface. Suppose this particular surface, suppose subtend an angle, okay, subtend an angle. So what I'm doing, I have a sphere, I'm just taking a part of the sphere, okay. Part of the sphere means a part which is actually not a line. This part, it is actually a spherical, this is a plane surface. Okay, this is a surface, not a line here. Okay, like if you just cut a portion of uh, the shot put ball. Okay, so that will not be a line, right? That will be a kind of plane surface. So now this plane surface, when makes an angle or subtend an angle here, this angle is denoted by omega, and this angle is called actually a solid angle. Okay, when I have taken here a nice all defined sphere, but I can have any arbitrary surface. Suppose there is a point here P. If any arbitrary surface, okay, or end of the surface, two end of the surface subtend certain angle, subtend certain angle, that angle is called solid angle. I'll draw once again. I'll just keep this sphere. I can take any arbitrary surface. That is what I'm trying to say. I can take, suppose this is a point P. Okay, I can take any arbitrary surface. Okay, any arbitrary surface I can take. So if this surface, the end of this surface is like C, this surface is say, is actually subtending certain angle at this particular point. Okay, at this particular point. All right. So this angle is called solid angle, and it is denoted by this symbol is actually, you see, in case of uh, resistance you have used this angle, but this is not ohm. This is actually called omega. This is called omega. There are omega like this also. Here you have omega this one. Okay, this is Greek symbol. So this omega is denoted for solid angle. Okay, or maybe vice versa. Solid angle is denoted by this, sorry, this sign. Now look, what is the definition of this solid angle? Suppose this has area dA or A, whatever, A or dA. Okay, and this has distance. See, from the area, this distance is r. Okay, this distance is r. Then solid angle actually is written as dA, the area which is subtending an angle at this particular point, by r square. Sometimes this A will be written as, area will be written as S also. So ds by r square. This is the solid angle. Okay, this is the concept of solid angle. Actually there are much more in the solid angle, but when you require I'll tell you, otherwise you'll forget. In your text this much is there. I can show you in your text. Whenever concepts are coming, like if we need to discuss still more, I'll discuss about solid angle later when I'll be teaching you some like context. In some context, if I teach you, I'll tell you further detail. So this is actually the this is the figure. This is a three-dimensional figure. You can see this is the area. So this area is subtending an angle over here. So this angle at this point. So this angle is called actually solid angle, and it is denoted by d omega here. Okay, I had denoted omega, same things. So d omega for this particular element of the area. I can take the whole sphere. So whole sphere, this area is how much? This area is 4 pi r square. So what will be the solid angle? Solid angle, whole solid angle. See, from here you can find out the total area of the sphere. Okay, so you have 4 pi r square. 4 pi r square. So you just strike the r square. See, I'll just write it here. So if I take, suppose this is d omega, I want to calculate the total angle subtended by the whole surface of the sphere. So I have to integrate, or I have to take the summation of this small elements, like here one element, area element, another area element I can take here. Okay, if these same elements you are taking again and again, then take the sum. Okay, you can take even sum also for all the elements. So you get, so what you get is dai, and r is constant always. This is r square. So this will give you, see, the total area will be like, look, this total area will be the area of the like surface area of the sphere. So this will be 4 pi r square, and this is by r square. So for a solid angle, what is the for a sphere, what is the solid angle? This I can write as 4 pi. For a sphere, what is the solid angle? Total solid angle will be 4 pi. Okay. So this is how solid angle is. Okay. This is what solid angle is. Now, what is the unit for this? In this case also, this is also, like this pi r square. This is pi r square for a 4 pi r square for a sphere. So 4 pi doesn't have any unit. So r square by r square. So this is also a like a unitless quantity, but still we denote this with, see, other one linear angle was denoted by radian, and this will be denoted as stay stay radian. It is called stay radian. Stay radian. Okay. And this, this in short is written as SR. This is stay radian, SR. Okay. So with this, uh, we just complete the solid angle and our plane angle. Now we'll just go to some other topics. So this, that is the measurement part. Okay, first let us see. So we are just now trying to measure length of objects. Look, we have many scales so far we know, like meter scale. Then you have a meter tape also. Okay, meter tape. You have, these are for bigger length, bigger or larger length, which we generally these are the lengths which are actually like meter scale. We use very frequently to measure the lengths which are actually accessible to us. Meter tape. These are the length or distance we measure with this instrument, which are accessible to our, like accessible to the meter scale. This instrument actually. See, meter scale, you have a huge length of this. Okay, that means, if you are given a 5 meter distance to measure, 5 meter distance, you take 1 meter length, then you just measure 5 times, you will get that length. Okay. If you are given 200 meter, 200 meter length to measure, or more than 200 meter, what you use is meter tape. Okay, what you use is meter tape. Understand? So this is how, whenever we are going for any experiment to measure anything, we need to find out a suitable tool or suitable instrument to measure the quantity. Like here I told, if it is 200 meter, we don't use the meter scale, we use a tape, right? Or maybe some other method we can use. Okay. But we cannot take a scale and go for measurement. Similarly, when we want to measure 10 to the power minus 4 meter, this is a very small distance, right? This is 0.0001. Okay, this much meter. It's a very small distance. So how do we measure this? Vernier scale, maybe. Vernier. Okay. Vernier scale. Sorry, Vernier ER. Vernier scale. You know what is Vernier scale? We'll discuss someday. Okay. Maybe in this class, next class, I'll take up screw gauge and Vernier scale. Okay. So Vernier scale. So Vernier, yes. Like Vernier scale, it is actually slide calipers. Slide calipers. Calipers. Sorry. There we use this. I think calipers K. Slide calipers. K is calipers. Okay. Slide calipers. So if you want to measure 10 to the power even further smaller distance, 10 to the power 5 meter, you use what is called screw gauge. Screw gauge. Okay. You use screw gauge. Okay. So these are the instruments, slide calipers and screw gauge. These two things I'll take for your understanding in the next class, and I'll tell you how to actually from there also the Barnier constant and then least count etc. are there, so which are actually useful things to learn. Okay, for practical purpose as well as our exam purpose. Okay, so so you can understand that these are the instruments which we can directly use to measure. Like see the diameter of the hair, diameter of hair. How do you measure? Okay, so such kind of things which you can measure with the screw gauge, like that. Okay, all right. So I hope it is okay for you. So these are actually, see, the distances or the length which are very much accessible to us, and uh, we can measure without much error with these instruments are called actually direct measurement. These were actually direct method of measurement of length. Okay, but suppose if I have to measure a very large distance like distance of planet from the earth, how to measure that distance? Okay, and again, suppose I have to measure a length which is very small. How much? Of the order of 10 to the power minus 10 meter. That means angstrom, even less than that, even less than this dimension. Okay, this length or distance. How to measure? So there is actually, see, there are indirect method as well. Indirect method. So we have used direct method. Just take the meter scale or screw gauge or the slide calipers to measure the smaller distance. Okay, but there are certain indirect method to indirect methods to measure very small distance as well as very large distances. But this method, actually these methods are not same method can be used for very large and for very small distances. There are different methods. I'll discuss that. Okay, so now look, if I have to measure the distance of a planet from the from the earth planet, from the earth surface, how to measure the distance of a planet? Okay, for that, you have to use an indirect method called parallax method. What is this called? Parallax method. So what is this method? You know, if you have a pencil over here, suppose you have a pencil. Okay, you have a pencil. So if you want to see the position of this, suppose in the background there is a wall. Okay, you just hold in your hand or maybe hold it somehow, this pencil, and keep just before the wall, and do one thing. You just keep your eye sometime here. Okay, that time, suppose this is your right eye, that time you just close your left eye and just denote the position of the tip. Obviously position will be somewhere here, suppose. Okay, I'll just increase this size. Okay, here. Okay, now you do one thing. uh Now you just close your right eye and open your left eye. Okay, left eye, and then you try to look this tip of the pen. So you'll see somewhere here. Okay, there will be difference between the position. Okay, suppose this is one position, this is another position. Okay, so this method is actually called parallax method. Okay, this is called parallax method. Parallax. there will be change in the position, okay, relative change in the position. This tip is actually, see, it is here for one eye, another for another tip, it will like another eye, the tip will be here. So this is called parallax method. That means, you know what I wanted to say. If I have an object to see like very large distance, okay, so how to see that? We'll be using our parallax method. Parallax parallax method. See, you might be surprised how this parallax method will help me. It will help, you know. uh, you will see that suppose this is the planet. Suppose this is a planet S. Okay, I have to look from Earth surface. This is Earth surface, suppose somewhere. So what you have to do, you know, as I have told you, that you keep your eyes, see, twice, like two places, once here, and see the same object. See, the angle of look will be actually, see, your inclination from with the horizontal is actually this and this. At least you are not seeing through the same path, okay, you are not seeing through the same path. One eye is seeing from this way, another eye is seeing this way, okay. Similarly, look, when I want to see an object using telescope from the earth surface, you just choose two positions on the earth surface. Suppose this is A. So from here, how you see like that. Another position, suppose B. This is B. So how you see this here, you see like this, okay. So the distance, suppose, between these two is B, small b. So AB is small b. I can measure the distance on the earth surface. These two positions I can measure the distance, suppose, okay. Now, now this distance AB is called base, actually. Base, okay. This is called base. And this is actually the angle. If this is suppose alpha, this is called angle, like angular, uh, I think angular separation you can say, or angular separation between these two, actually these 2 points, or I can say that this is the angle between the line through which, or between the direction through which you have seen the planet from two position on the earth, okay, two position on the earth. So this is the angle between the lines through which you have seen the planet P here, or sorry, yes, I have. So planet or stars or whatever. So you have seen in these two directions, and the angle between these two, this is called actually this is uh, angle of parallax. I can say. I'll just see the exact term in your book. So so this is called angle of parallax, okay, or parallax angle or parallelic angle. That angle here I'm writing as alpha. So in your book it is given as theta. Maybe we can take the same notation. So this is called parallelic angle, okay. Look, then I'll just write this as theta, okay. Parallelic angle, this theta is actually parallelic angle or angle of parallax, or angle of parallax, okay. So this theta, now you look, this I know, AB distance I know. If I get this distance, actually I have to get this distance, right? This D, this is the D. From the earth surface I have to get the distance of the star, or the planet. So this is the perpendicular distance I need to find out, okay. I need to find out perpendicular distance. So if I know the angle theta, so I can know this angle as well, right? All right or not? We can find out this angle. Okay. So you can see this suppose this is a perpendicular bisector, so you can take this as b by 2 and this is theta by 2. Okay. Now we have learned the definition of the angle. So theta by 2 I can write. So this distance, uh, so this is the radial distance. Okay, this is the radial distance. This suppose this is the arc of the circle of radius d. This is AB length is the arc length of the circle having radius d. So I can write this arc length b by 2 because I am writing for theta by 2. So this is b by 2 divided by radial distance d. So 2 goes up from both sides. So theta will be actually b by d. So I have to measure this distance d. So d will be actually b by theta. And you know this theta is very small. That's why I am writing. See, I can write even tan theta. Tan theta is equal to perpendicular by base. I can write from there also. Tan theta by 2. I can write as perpendicular d by b. Okay, d by b. All right. Oh, okay. I have done a small mistake. Maybe no. It's okay. So you look. So from the geometry, we can find out the perpendicular distance. I'll just go for your book. Look here. So we can find out d is equal to b by theta. Okay. See, this is b. This is your d perpendicular distance. So you can find out easily. So what is so this is the radius is the d I have supposed, and this AB I have taken as an arc of the circle having radius d. So b will be r like d capital D theta. So from this figure we can find out. See, I know the angle between two directions because I while measuring like while seeing the object here through the telescope, I know at what angle I am just looking, and from the telescope again I can get the angle between these two AS and BS. I can get the angle between these two lines. So what I have to do is I have to just know the distance between the 2 points on the earth surface, and I need to know the angle between these two directions through which I'm seeing the object from these two places. So once I know these two, I can easily find out the perpendicular distance. So see, look, this distance they have taken as perpendicular distance. Okay, AS or BS has been taken as perpendicular distance. Why? Because this angle is thought to be very small. If this is very small, okay, I'll just show you what your book has taken. I'll just copy this figure in my presentation. Look here, they have taken this AS or BS as perpendicular distance from Earth surface to this star or planet, whatever you say. You might be thinking, sir, how is it possible you take this? Say you have drawn like this perpendicular. This I agree, but how do I agree with this? Actually, you can agree with this also because see, I can tell you this theta is actually, see, theta is given by b by capital D. So this is a distance, a very large distance. This one is a very large distance. The D is very large. If D is very large, but this points, so this actually length, the length between A and B is fixed. Then what is the value of this angle? This is very small. If this is very small, look, this can be like this, it can be like this. So I have angle like this, but I can reduce the angle suppose like this. Okay, so you can eventually find out when the angle is tending to 0, this theta is tending to 0, then this AS and BS will be perpendicular. Sorry, AS and BS will be perpendicular to AB, which is D. Okay, this you can write. Deepa, so far have you understood whatever I have taught? What do you think? Do you understand parallax method?
Yes, sir.
If no, please say. If no, please say no. If yes, then also I am happy. If no, then also I am happy. If no, then I have an opportunity to teach you again. But if you say yes, but you don't understand, that is very bad. Do you
I understood.
understand parallax method? How we measure large distance? Okay, nice. So yeah. So with this method itself, so once we know the distance d, or the distance from the earth surface to the planet, then I can use the same method to uh, measure the diameter of any planet or star. Like if suppose this is moon, okay, this is moon. I need to find out the diameter of the moon from the earth surface. So how to do that? We'll be using parallax method. Suppose I have used the parallax method to know the distance of this moon from the earth. I have got this distance practically. Now look what I can do. I can do the parallax method in the reverse way, like this. I will try to see the both end of the moon. Okay, maybe I am taking the full moon from the same point of observation. Same point of observation. Okay, from the same point of observation, if I see a look, the two ends of the diameter, two end points of the diameter of the moon, then look, there will be angle between here. Okay, angle. This angle, suppose here in your book it is written as alpha, and see this distance is d. This is the perpendicular distance I have got already. And look, I have to find out this AB. Then only, see, this is A, this is B. Suppose I can find out. See, I can find out directly what is the diameter of this object. If I know the d, I can use this way to find out the d, and use the other way like this. So here in the previous case, see, there are two observation point on the earth surface, and from where we are just looking the object. Okay, at two different places, through two different places, we see there will be the angle of parallax, angle of parallax. So in this case, the angle of parallax is actually at the earth surface, and in the previous case it was different. Geometry was, it was little different, otherwise nothing else. So I have to find out AB. So look here, this is actually your alpha. So this alpha will be actually AB, which is the diameter we need to find by D. Okay, so I know the angle, right? Now I know the angle, so I have to find out AB. AB will be actually D into alpha. Okay, so once you know this AB means diameter, okay, to R of this planet. So once you know the distance from the earth surface to that planet by parallax method, then you can measure the angle from like angle of the vision, like angle between the vision of the sun from same point on the earth surface here, sun or moon. So for both ends you can see, and you can get the angle of parallax here like this, and you can find out the diameter of the planet. Okay, so this is what actually was today's lesson. Okay, so this is what was today's lesson. So what we'll do, we'll just try to uh, do at least one numerical example on this. Before I go there, numerical example, what I'll do, I'll urge you to read few conversion of degree, angle, minute, like the angle, like see angle and radian. See here we have got 360 degree means 2 pi radian. Okay, 2 pi rad. Then what is 1 degree for? Okay, how much radian is for 1 minute? Sorry, 1 degree. Then how much for 1 minute, and how much for 1 second? So these are actually few things which you have to either remember or you can calculate by yourself during your exam when you may require to convert from degree to radian, radian to degree. See here, this this is a degree sign, you know that. So 1 degree means pi by 180 radian. So this value will be 1.745, 1.745. So this is the into 10 to the power minus 2 rad. Then 1 degree means 60 minute. So minute is given as only one prime. Okay, minute. So 1 minute will be actually 1.745 into 10 to the power minus 2 by 60. So you'll get for 1 minute. So again, if you just write these two, then it is called 1 second. That means you can just do one thing. You can divide this with, so this is 60 into 60. Okay, so then you get this number, I guess. 1 minute is this number. Okay, so this will be, so anyway, so you know this. So this conversions you have to do by yourself whenever required. Okay, now I'll show you. You might be thinking, sir, why you are talking me this thing. Look, we have an example in your book itself. Oh, sorry. This is the book. Suppose we want to see Deepa. I hope you are able to see the screen. So read this 2.4 example. Read this 4.2 example,
Yes,
and
sir.
then can you try to find out? Can you try to find out this? So sun has angular diameter. Angular diameter. That means the base length of the base. I have told you what is base, right? I'll tell you once again. The angular diameter is, or angular length, I told, I think. Angular length or angular diameter are the same things what I have told there. So look, I was telling you in the parallax method, you are seeing an object from 2 points A and B. So this distance is called angular diameter. This distance is called angular diameter or base of the base. Okay, angular diameter or base. Okay, so here it is. See, I'm trying to use this parallax method to find the diameter of the sun. So I have to do like this. Okay. Okay, so the sun is here, and you are, okay. No, no. Actually, you have to do diameter means sun is here somewhere. Okay, two ends you have to look, and here the angle at the surface. Okay. Uh,
Okay.
so you look, yeah. So these parameters are given. Few parameters are given. You just check what are given, and then using those parameters, can you find out what is the diameter of the sun? Sun has angular diameter. This is given already. Measured to be, oh, I am sorry. Actually, angular diameter means the angle. Okay, angle of parallax here.
Yes,
Here,
sir.
angular diameter. What they wanted to say. This is actually angle of parallax, not the angle of diameter.
Yes, sir.
That is okay. Where? Okay. So here they have given angle of parallax as the angle of diameter, angular diameter here. In this actually you may need calculator. Distance d is given from the earth, that means the perpendicular distance, you know the angle, then you have to find out the diameter. Are you calculating that?
Sir?
Are you calculating? Are you calculating this? I was thinking that you can just calculate it and see.
Yes, sir.
This is an example problem, but still these examples will help you to understand the concept. Okay, so better to practice the example. So for now, I'll just show you from here what we have done here. This is actually, see, this angle is 1920 second. This is the angle, very very small angle. So the distance, perpendicular distance is given. So that I can take this d, capital D is a radial distance, and then what, the definition plane angle. So angle is equal to, or this diameter will be equal to d into this angle theta. Look here. So this angle, first of all, you have to find out in radian. This is in given in media, like given in second. Second, like 1 radian, like you have to then find out this much second means how much radian, because we have to find out the diameter in terms of length. Okay, that's why you have to find out the radian first. This much 1920 means how much radian you have to find out. Okay, so in the previous, see, in this case we have seen this is the second. Okay, 4.85 into 10 to the power. So here maybe you can see 4.85 into 10 to the power 6 is radian. Okay, 1 second means this much radian. Okay,
Okay, sir.
so use this, yeah, use this. So this much radian, so alpha you have got this much radian into d you have got this much length. So multiply these two, then you get, this is the diameter of the sun approximately. Okay, so this indirect method is an approximate method. You will not, since we are not able to measure with tape or anything else, so we have to use indirect method like this. This is parallax method. On the next day, so do you understand this thing? Do you understand how they have done for this problem?
Yes, sir.
Deepa, you have to tell me here, okay? Otherwise you lose the concept or lose the knowledge. Okay,
Okay, sir.
so I hope you have, yeah, you have understood. If you don't understand, you can tell me in the next class. You just try to look all the examples over here. Okay, all the examples over here. If you have certain, like, any problem in any example, first you ask me, sir, this example I could not understand. Okay,
Yes.
then we'll move forward. Okay, I'll clear your
Okay.
doubt and then we'll move forward.